Okay, we're on IXL and we're talking about circles and geometry. And that circles can seem, all the geometry can seem a little funky because the formulas on the formula sheet look like they're written in a secret code. And, cool, we flip to it in the test and they go, okay, you needed the area of a circle, and there it is. And that is written in, that's two different languages. That's Greek and the old phonetic English letters. So what exactly do we do? Well, here's the good thing. Anytime we have to use, there's that symbol right there. That's called pi. Anytime we have to use that in every single question, it'll tell us, hey, all we need is 3.14. That's all we need. And as a magic number for circles, anything round. So spheres, balls, cones, anything like that. We have a base 10 number system because we have 10 fingers and 10 toes. And it works great, except for two things. The number 3 and circles. So if you divide 10 by 3, you get 3.33333. You know what I mean? It just never divides equally. And when you do circles, this number pi stands for this number that is a decimal that goes on forever and ever and ever. It never resolves. So all these computers are calculating pi, and it's just an infinite decimal, which is sloppy, or it doesn't fit into our system very well. So here's our formula. A for area equals pi r with the little number 2. So we want to imagine we're in the test. Here's what we want to remember. We want to rethink a circle. We don't want to think of a circle as this round hoop. Instead, think of a circle this way. A circle is a line, except one end of the line is sitting perfectly still, and the other end of the line is moving exactly the same distance around it. You know what I mean? And that's what draws the circle. The defining part of a circle is that line. So if I wanted to draw this circle, I'd have a point here, and then I would spin this thing around. So it's like you have a whistle on a string, and you're spinning it. The thing that, all the person really sees is the whistle. Well, the thing that really draws the circle is the length of the string. If the string was half as short, the whistle doesn't change. The whistle is just being a whistle. Yeah. But if the thing was twice as short or half as long or whatever, the circle would change. So what we need more than anything else is that number. That is called the radius. So I had a teacher that I went to Catholic school, and this one teacher's terrifying. And she would point to her nose, and she would say, this is the circle. And she'd point to her nose and say, my nose is the center of the circle. And then she'd stretch her arm out, and then she'd make a little gun. This is before, paranoia about guns in schools. And she says, this is my ray gun. And she was funny. She would say, look at, and she's like, get the mental image of a nun holding out her, pew, pew, or whatever. It's crazy. But I can't get it out of my head. It's, decades later. So she'd say, that's my ray gun. That's what we need to know. And she's like, just like you can't forget, an armed nun, Sister Dorothy.
Right.
She's still alive. I looked her up. And so she said that. So that's the defining thing. That's like the magic thing. And that's why in this formula, there's really only one number we need. And that's how long is the string. Now, there's another number they can give us. So if we imagined a basketball hoop doesn't have a center. The center's air. So if we wanted to measure something about a basketball hoop, the only thing we could do is, let me change my pen color, is measure from side to side at the longest possible way. If I put a tape measure here and all of this is air, I could just reach it and go, okay, when it's at its longest right there, I can measure that. And when we know that, it crosses through the middle, and that's called the diameter. So the diameter is something that they'll give us sometimes. It's not what we want. We want the radius.
Yeah.
But that's not going to be a huge problem because as soon as they say diameter, this is what the nun did. I'm serious. She's crazy. She put out two ray guns and she sort of spun around. She said, "If I keep shooting, everybody's going to die." I'm like, "You're nuts. Why are you a nun?" Anyway.
Right.
But she sticks in my brain. So if they give us the diameter, we got to cut that number in half, and it makes sense because if I'm going to change it to green, if this is I know that says 1, but let's say this is 3. That little thing, that the whistle string is 3 feet. Okay, that's pretty big. If this is 3, then the line from here to here is 3, and the line from here to here is 3. So if this part is 3 and this part is 3, then the diameter is 6. So the diameter is always twice as long. So that's not too bad. You know what I mean? So right now we just discovered how they're going to try to trick us with the question. We're always looking for the radius, the string. You know what I mean? Yeah. So now they gave us, I love IXL. I love IXL because they give us these questions that are pretty straightforward. And then we're at 0 points right now. And it's 9:56 a.m. on a Wednesday. By the time this thing says 100, it'll climb up to more tricky ways of asking something.
Yeah.
But the core math will not change. And I love that IXL just sort of lives in a skill, teaches it straight ahead, and then goes, okay, you're in a house, knocking on the front door, breaking in the side window, coming down through the chimney. They're going to just start coming out in 15 directions. And we're like, I'm fine. Yeah. I know what the math is. So here's the math. Let's do green. So area equals pi r with the tiny little 2. This will always be written there. So we could substitute 3.14 for pi anytime we want. I'm going to wait till the end. And again, she said that because she said save pi for dessert. Isn't it crazy what sticks in your head? So I'm just going to write that again. So, and then we got to remember in this kind of math, in algebra type math or whatever, algebra and math, anything touching each other multiplies. So there's a tiny little invisible times dot there. So pi is going to multiply with whatever this works out to be. So I didn't do any math yet. All I did was kind of rewrite it and remind myself that there's a times dot between those two. Now the R is the string. So we're always going to talk in terms of the string, not the whistle. So Holland, Ohio. Who's calling me from Holland? Well, you can wait. Oh, it's a pharmacy. All right, anyway. Here they're saying the radius is 1. So if the radius, I'm going to erase the R and put in a 1. And you're going to be blown away how simple this math is. So there's the 1. Still haven't done any math yet. R to the second power, we always want to think of those little numbers as repeaters. All they say to us is how many times we multiply 4 by itself. It's like we talked about looking down in the silverware drawer and there's stacks of spoons, and we don't know, if we can't tell how many spoons are there, that little number says how many spoons are there. So if there was, how many 5s are there? Well, there's 3. They're all stacked on top of each other perfectly. So this means 5 times 5 times 5. So it's just a little repeater. We never, ever want to think it's 5 times 3.
Right, okay.
You know what I mean? So like we said, that's a rule. Everything touching each other multiplies. So it's like the 2 are stacked on top of each other, and that little number tells us how many there are. So that means I'm going to change to red. Again, we haven't done any math yet. All this means is 1 times 1. Because I wrote it twice, 2 times. 1 times 1 is 1. Now I'm going to change pi to a real number, because pi is for dessert. It goes last. 3.14 times 1 is 3.14. And that's our answer. It's crazy.
Wow.
So right now, and I'll type this in here in a second, and it's going to say wonderful, good job, or all the stuff, the encouragement that IXL does. all that's really going to change is the length of that number. That's the only thing that's going to change. What will change is how they ask it, right? They gave us a picture of a circle. At some point, they're going to stop giving us a picture of a circle and they'll just describe it. You know what I mean? Or they'll give us the diameter, or they'll turn it into a word problem, and they won't mention the word circle. There was one about like a fountain, a big circle round fountain. You know what I mean? And they asked the question about the fountain, and you're like, they never said the word circle, but they just said walk around or whatever. You know what I mean? So that's what they do. So that's why we think this is an aptitude test and not an academic test. That once we know this, and that math is not hard, we're going to be all right. And all we got to do is figure out what to plug into what. So I'm going to type in 3.14. It'll probably say the word great job. Awesome.
Awesome.
The only thing changes is the string. And look at, I mean, again, it's what, 6 minutes later, it's 10 o'clock. This formula stays the same. We know what pi is. We save that for later. If we can remember, there's a times dot there because everything touching multiplies. It just happens like a chemical reaction or whatever. I'm going to put that over here on the side. This repeater, I'm sorry, this number is the string. So I'm going to erase the R and put a 4. And so we remember on the GED test, they give us a little whiteboard and it's not very big. You know, I have one around here somewhere. This room is such a colossal mess. But it's smaller than a piece of paper. It's not very big. It's bigger than a notepad, smaller than a piece of paper. So we got to like conserve space. So once we do that, all we remember is that's just a repeater, 4 times 4. We can use our calculator on everything. We don't have to memorize any of this junk. That's 16. Then we buy for dessert, save that for dessert. Now whatever 3.14 times 16 is our answer. And that sound, what you just said, it'll always be a decimal. Well, not always, but it'll be a decimal. And when we get a decimal on the calculator, it's kind of like, I don't know if I did that right. With circles and threes, we're gonna get decimals. So we gotta be okay with that. So 50.24. Now it'll say awesome, it'll say good job or whatever, but they'll probably take away the picture of the circle. They'll probably change the wording. They'll probably only give us the diameter. And then there's one last thing that they will do for sure, and that is instead of giving us the string and asking us what the area is, they'll turn it backwards and give us the area and make us work back to what is the string.
Oh.
Yep, there. So that's when they turn and they stack a geometry skill and an algebra skill. Because algebra is about the unknown thing being in the question. And that's where we got to be able to be confident enough to break those things apart. And we'll be able to do that. Also, our wicked awesome calculator that they give us for the test, which again, no idea. Where'd I put it? If you want some pretzels, I got some. and a little candle holder thing because my dog right there, whatever.
You can open your little stove gap.
And 3 pairs of sunglasses. So I got all that, but I can't find my calculator. But on the calculator, there is a button for pi. So you don't even type 3.14, but type in 3.14 that's all they'll ever ask. Like I said, the decimal goes on forever. So it's kind of cool to be in control of it and just let pi be pi and wait to the end and then unpack it. And there we go. All right, so I'm going to pause this recording. So one of the things they can do is give us a nice awkward number like 47.
Mm-hmm.
And that they're testing us. Don't rely on our mental math. Maybe if it was 4, mental math would be very easy to go 4 times 4, but still, we want to use our calculator. We want to let ourselves be tired on question 20 of a 46 question test. So I just type in 47 times 47, get my number. And now I know I'm going to get I forgot to draw the 9. I'm going to get a big old number here. And here's what the choices would be. If remember, GED is multiple choice. Sometimes they do this, and they go, look, we'll give you all these squiggly numbers. Grant you that. But if this is only 47, does that seem a little big? Maybe you're wrong on, you know what I'm saying? So that's, I mean, they have always an answer that's the right answer, and then a lot of times they'll have the distracting answer. The distracting answer is there to sort of lead us away. Oftentimes, an answer will be something that's on our calculator, but we're not done. So in this problem, we type 47 times 47 in our calculator, and 2209 is the right number to get to, but it's not where we stop. And 2209 could be one of the choices. And that gets very tempting to go, well, it says on my calculator, I must have figured it out. I'm pretty smart. And they're putting pressure on our method. Remember, fatigue and distract. That's the 2 things they really want to do to us. But we are rock solid. And that's sort of a good feeling. We don't want to give, this test so much reverence and respect that it's asking stuff from on high. No, they resort to tricks. And we got to be, it's like figuring out what a magician does. And then you get to look at the magician and go, that's what you do all day? That's sad. So here's a curveball the GED can do, and let's say how. Remember, the math so far hasn't been so bad. So when I go to Little Caesars, I buy a bunch of pizzas or whatever, and because they're only $5 and all that stuff, and I buy one extra and put it on top, and that's my road pizza because I will eat it all by the drive home. Just pathetic because it's always hot. You get the grease stains on your shirt and all that stuff.
Right.
So, and then I get to come home and say, I'm good. You guys have your pizza. Oh, Dad, thanks for sharing. Whatever. Oh, pathetic.
Right.
So here's a GED question. They would say, there was a pizza, and then Jeff walked by, and half the pizza's gone. So I'm going to draw this in pretty sloppy. So this part of the pizza is gone. That is art. In other words, it's a semicircle question. And they're going to ask, well, the diameter of the pizza is, I don't know, 9 inches. So, no. There's like a standard for that. 14 inches. 14-inch pizza.
14, yeah.
But that's the diameter. And half of the area or half of the pizza is gone because I'm a pig. And what is left? So that's one curveball they can do. Now, the math we were doing doesn't change. And here's that formula. We got a Greek letter, that letter, and that letter. So we got to do 2 things. One, they gave us the diameter. We don't want the diameter. We want the length of a slice from the center to the outside, where that stupid little plastic table is.
Yeah, I know.
So we got to cut that in half to get to 7. So 7 times 7. I forgot to put pi over here. Pi's just going to sit for a second. Now I'm hungry for pie and pizza. I'm drawing this out of order. So we would do 7 times 7. So that's 49. We got to write in our little times dots. And 3.14 times 49. 3.14 times 15386. That's 15. What the heck was that? Just dropped my phone. 153. What was it? 86. That will be one of the choices. Okay. And it will be wrong because that says the area of the whole pizza. And we have to remember, just like when they gave us diameter and we have to cut it in half, we just worked out the area. That's all this thing's job was to do. Now I just drew the anarchy symbol and put a circle on it. So we got to cut that in half. But what's diabolical, and we'll figure out what that is. What's diabolical about the GED 7693 is that this will be one of the choices. So that's one tricky thing they can do. So how do we guard up against that? One is we want to approach each question not as an attack about what we don't know, because that's entirely negative. You know what I mean? And yeah. I'm going to describe two people taking the GED math test. One person is confident and, walking in there just kind of strutting. You know what I mean? Like, but it's like me and my wife. I was shooting way above my game. I don't know what, lucky stars or whatever. You know what I mean? They look at us together and they're like, "Oh, this is your dumb brother," huh? I'm like, "Nah, it's my husband." So, to be that guy and go, "Yeah, I belong here." You're like, "No, you don't." There's that guy that's walking in and going, "All right, I did my work. I know my stuff, blah, 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 blah." And they get to a question and they get it wrong. And then there's another person that is just bringing anxiety and negativity and just, man, I don't know. Man, it's always been tough, blah, blah, blah. And they get to a question and they work at it and they worry and they worry and they do their math twice and all that stuff. And they get themselves so frazzled that all the possible answers look right. And they choose this one and they get it right. I would rather be the first guy, because the second person doesn't know they got it right. And all they're bringing to the next question is worry and being a little bit more tired.
Yeah.
So I would rather, you know what I mean? And that's what I was saying to you about you before. You see a speed bump, but you're like, okay, we just got to navigate the speed bump and we're going to be on the other side of it. We're not going to fall in love with the problem. We're not going to fall in love with how, crazy they can come with the question. Instead, it's like dealing with 3-year-olds. As soon as you figure out how to deal with a 3-year-old, man, that's a pretty decent skill, because they're going to come at you in 19 different directions. They're going to glue the cat to the wall. They're going to start the refrigerator on fire, whatever. They're going to do stuff. And we're going to be like, I can handle that. I can handle it. So those people, I don't know what that thing is. I'm dizzy for pizza right now, apparently. So this is called the distractor, that will be one of the choices. And since they resort to those games, I'm going to draw a box around the math. Sometimes they're not really worried about the math. Sometimes they're more worried about our focus, or testing our ability to be distracted, or, the old, "Are you sure?" Like Deal or No Deal, and all those games where they would like, "Are you gonna," some big $1 million decision, and they'd say, "Are you gonna?" "Okay, we're gonna go to a commercial." You know what I mean? Just to make you think about it. Yeah. So they can do that. And then another thing is, and this is a technique, when you go to the test, wear a piece of jewelry that you don't normally wear. Like, I don't wear watches, but I would go wearing a watch. And because it's an unfamiliar thing, And the reason I gave my wedding ring to my son when he went to go take his SAT. And I said, the only reason you're wearing this ring when it sort of, feels uncomfortable or whatever, is to remind you, before you choose your answer, to look at that question one more time. You know what I mean? That's all it is. Am I playing honest with a dishonest question? You know what I'm saying? So like this missing half pizza thing, I did all the math right and they gave me the halfway answer. So wear something to remind you to look at the question mark. Go back to the question mark and go, that is the only thing that matters, is what are they really asking? So, don't have to pierce your nose or anything like that, but you know what I mean? Just something different. So, and that way, at the end, when we go to hit our answer, we also take a pause, take 2 seconds, and go, deep breath. I don't know what the next question is going to be, but it's more of a puzzle to figure out than it is a question. It's not an accusation. I can figure stuff out, because adult learners are figure outers. That's what we are.
Yeah.
We've all had jobs where we were trained by an assistant manager who did a cruddy job training us, yet we still
Mm,
figured out what to do.
right.
Beauty of the grown-up mind. We don't learn like kids where it has to be on a string.
Hmm.
We can throw ourselves into situations, figure out what to do. So
Right.
this is a great area for confidence in math. This area, and that was a fun. Uh, cool, cool,
Okay.
cool, cool.